Assalamualaikum and a very good day. So today we are going to learn on chapter 6 on the hypothesis testing. Okay, so in this chapter, okay, we are going to use the Z table and also the T table. So your Z table is from table 3 and your T table is from your table 7. Okay, so in this topic, okay, we are going to use the formula, okay, in order to solve our problem. So first, okay, we are going to look, okay, the definition of the hypothesis. Okay, so the hypothesis is the statement about population parameter. Okay, so in this hypothesis, okay, usually we have two types of hypotheses. Okay, so the first type is the null hypothesis. Okay, which is denoted by H naught. Okay, and also we have the alternative hypothesis. Okay, which is denoted by H1. Okay, so please keep in your mind when we said about the hypothesis, we have the null hypothesis H naught and also the alternative hypothesis H1. Okay, now so we also have the hypothesis test. Okay, okay, this hypothesis test, okay, is come from the question, so we must make a decision, okay, whether we want to reject or not reject the H naught. Okay, so that's mean in this topic, okay, our aim, okay, our final solution is whether we want to make a decision to reject or do not reject the H naught. Okay, okay, so in this H naught, okay, we usually have the equal sign. Okay, in the H naught we have the equal sign, and for your H1, okay, it must refer to the question. Okay, but okay, there will be three possible H1. Okay, the first one is greater, the second one is less than, or the third one is not equal to. Okay, so for H naught, it must be equal sign. Okay, let's say you have, okay, the mean, let's say we use is equal to 7. Okay, this one The equal sign is for the H naught. But for the H1, it must refer to the question. Let's say the question says that the mean is greater than 7. That means your U is greater than 7. Okay? Or it can be your mean less than 7. Or it can be your mean not equal to 7. Okay, this H1 must be referred to the question. It depends in the questions. Okay, now, if your H1 is greater or equal, okay, that means this is the one tail test. What does it mean? Okay, when it greater than 7, that means it's a right tail test. Then, if your mean is less than 7, that means it's a left tail test. But if your mean is not equal to 7, that means it's a right left tail test. Okay, it's both. Right, left, tails test. Okay, so now let's look. Okay, now so let's say we have our H naught. Okay, new or mean is equal to 7. Okay, this is our H naught. Okay, so the question can be, okay, H1 in which our mean greater than 7, one tail test, okay, and it's a right tail test, okay, or less than 7, left tail test, or our mean is not equal to 7. That means it can be right tail test or left tail test. Okay, so for one tail test, okay, we will have one alpha. Okay, significant level alpha is equal to alpha. But when it comes to two tail test, then you must divide your alpha by 2. Okay, again I repeat, when you have one tail test, okay, that means it can be right tail test or left tail test. So your alpha, your significant level is alpha. Okay, how to get the alpha? It's come from the question. The question will give you the information of the alpha. Okay, so the alpha is equal to alpha. But when it's come to the two tail test, you must divide your alpha by 2. Okay, so how about the rejection region? Okay, now before that, okay, we look the definition of test statistic. Okay, so what is the definition of test statistic? Okay, it's a sample statistic used to decide, okay, whether to reject or fail to reject H naught. Okay, now our aim, okay, is to make a decision whether we want to reject or do not reject the H naught. So this test statistic, okay, it can be your Z test, okay, it's come from your Z table, or it can be your T test. Okay, how to get this Z test and T test? Okay, it's come from the formula. Okay, so we will look at the formula later. Okay, but we must calculate, okay, the Z test and also the T test. Okay, so now what is the critical region? Okay, so this critical region is the set of all values, okay, which cause us to reject the H naught. Okay, what is the value? Okay, so it's come from the critical values. Okay, these critical values, okay, that is the value which separate the critical region from the non-critical region. Okay, so we look at this definition. Okay, now let's say, okay, we are given the alpha is equal to 0.01. Okay, so we are given the alpha is equal to 0.01. Okay, so from this alpha, okay, we must get the critical value, okay, ZC. Okay, so how to get this? It's come from your table. Okay, if we use the Z test, that means we must use the Z table. But if we use the T test, that means we are going to use the T table. T means the critical value. Okay, for Z test, TC means the critical value for the T test. Okay, so let's say our alpha is 0.01. Okay, let's say we use the Z table. Okay, we use the Z test. Okay, so how to get the value of 0.01? Okay. Okay, this is our Z table. Okay, it's come from the table 3. So 0, we want to find the critical value. Okay, so that means our critical value is here. Okay, this is our critical value. Okay, so we are given the alpha is equal to 0.01. So it's come from here. Okay. Okay, 0.01. Okay, so it's near to. Okay, so it's come from here. Okay, 0.01. Okay, out here. So we take in the middle. Okay, so we have 232. Okay, plus 233. Okay, 232 plus 233. Okay, so our Z, okay, 0.01 is 2.32 plus 2.33. Okay, so we take the average, then we get 2.325. Okay, so we get our critical region. Okay, for ZC is equal to 2.325. Okay, so our ZC is 2.325. Okay, so now our ZC, okay, we already get our critical value. Okay, so now this one is the critical value. So what is the critical region? Okay, now, so this is our critical value. So the definition of the critical value is the value that separates the critical region and the non-critical region. Okay, let's say if we have a line, okay, let's say this is our 2.325. Okay, so this is the line. So this line, okay, it separates the critical region and also non-critical region. Okay, so we know that this is a right tail test. So the right is the rejection region. Okay, and this one here do not reject. H not. Okay, that's mean. Okay, this is our critical value. Okay, we already get for 0.01 is equal to 2.325. That means we already have the critical value. Okay, separate the rejection region and do not rejection region. So right tail test, that means this is the rejection region and this is do not. This is the non-rejection region. Okay, so now we must use the test statistic. Okay, so let's say we in this one we use the Z. See, that means it's come from the Z test. Okay, so we must use the formula. Okay, the formula will be given. Okay, for the Z test. Okay, let's say we have the Z test is equal to 2.22. Okay. Okay, by using the formula, we calculate and we get our Z test is equal to 2.22. Okay, now 2.22 is here. Okay, so this one is 2.22. Let's say. Okay, 2.22, that means it falls in the non-rejection region. So that means our decision is do not reject H not. Okay, so now we use the same example. Okay, left tail test. Okay, so left tail test. Okay, that means we have 3.325. Okay, this one is a critical value. Okay, now how to determine which one is the rejection region and which one is non-rejection region? Okay, if the left tail test, that means this one, okay, is the rejection region. And this one, non-rejection region. Okay, now, if we get our Z test 2.22. Okay, sorry, this one for the left tail test, okay, it must have the negative. We must add the negative. So that means our rejection region is we reject H naught if our Z test, okay, falls in the region ZC less than negative 2.325. Okay, then we have our Z test is 2.22 is come from here. So that means we do not reject H naught. Okay, it goes same. Okay, so for this one, okay, we can say that we reject H naught if our Z test. Okay, how to get the Z test? We must calculate by using the formula. Okay, reject H naught if our Z test falls in the region of the ZC greater than positive 2.325. Okay, that's mean when you get 2.22, so we do not reject lah. Okay, so now we look at this example. Okay, now we have alpha divided by 2. Okay, that's mean when your alpha is 0.01, you must divide by 2. Okay, then you will get, okay, 0.01 divided by 2, then you get Z 0.005. Okay, so if you look from the Z table, okay, for the critical region, you get your ZC is equal to 2.575. Okay, now, so we have the right tail. Okay, so this is our critical region. Okay, let's say we have 2.575. Okay, we have two. One is for the right tail and one is for the left tail. Okay, so for the right tail we have the positive and for the left tail we have the negative. Okay, so this, okay, critical. Okay, separate the critical region and non-critical region. So positive, this one is the rejection region. So for the negative, this one is the rejection region. Okay, so now if you get your Z test is equal to 2.22. Okay, 2.22 is around here. Okay, so dia tak masuk. Okay, it's not fall in the rejection region for the right tail and also the left tail. So this one we do not reject H0. Okay, this is how, okay, we make a decision whether we want to reject or do not reject the H0. Okay, so now I already explained on how to make a decision. Okay, but I skip, okay, how to calculate the Z test, okay, or the T test. Okay, now we will look the formula of the Z test and on the T test. Okay, in this hypothesis testing, okay, we have two types. Okay, one is for the single mean and also for the two means. Okay, so for the single mean, we have mu, we have single mean. Okay, that's mean we have only one mean. For two mean, we have U1 or mu2. Okay, we have mean 1 and mean 2, or we have mean A and also mean B. Okay, so for this video, we are going to look only on the single mean. Okay, so the single mean, okay, we have two types. Okay, the first one, when your population of standard deviation is none, and when your standard deviation of population is unknown. Okay, so we have two types. Okay, so when your standard deviation of population is none, okay, we have two cases. Okay, the first case is case A and the second one is the case B. So for case A, when your N is greater or equal to 30. For case B, your n less than 30. Okay, that's mean for case A, large sample and also the small sample. Okay, for this one, we are going to use the formula of z-test. Okay, the mean of the sample minus the mean of the population over the standard deviation of the population over the square root of number of sample. Okay, so that's mean for the single mean, when your population of standard deviation is known, we are going to use the z-test. Okay, now, how about when the standard deviation of the population is unknown? Okay, we have the case A, okay, in which your n greater than 30. Okay, for this case, we are going to use the z-test. Okay, in which the formula of the z-test is same, okay, with this formula. Okay, but okay, the population standard deviation, okay, the standard deviation of the populations, okay, is unknown. That means we use the same formula, okay, but we use the standard deviation of the sample over the square root of number of sample. Right. For the case B, okay, in which your n is less than 30, okay, our t-test, okay, we are going to use the t-test. Okay, the formula is same, okay, but for t-test, okay, your alpha and your v, okay, your alpha is different from the question, but your v is equal to the n minus 1. So that means n is the number of sample minus with the 1. So for the t-test, okay, you are going to use the t-table. Okay, that means for the single mean, okay, we are going to use the z-test, in which we are going to use the z-table. Okay, table 3. But for standard deviation, population is unknown, in which your n is less than 30, we must use the t-test or t-table, in which your degree of freedom, your v, is equal to n minus 1.